Now we are looking at perfect inelastic collision. The case being, we're looking at the loss of kinetic energy in terms of difference and in terms of ratio. So there's a special case. This is a special case. We have the second object to be at rest. And post collision, they move as one. That's why it's perfectly inelastic. Now, it's kind of simple. So we have kinetic energy before collision. Kinetic energy of the system before collision. Of the system before collision. So kinetic energy is given by half mv square m1 u1 square plus 0, right? The second object has no kinetic energy. Next, you have kinetic energy of the system after collision. So we have kinetic energy after collision is half m1 v square plus half m2 v square, because both move in the same with the same velocity. This would be the case, and then we have half and v square common, m1 plus m2 basically. Now, change in kinetic energy. So basically, change in kinetic energy is equal to kinetic energy final minus kinetic energy initial. So final is half v square. Then you have m1 plus m2 minus half m1 u square. Okay. So simplification we can do. Actually, we need to substitute for v. Then we can further simplify. We need to express in terms of u and everything, So I'll substitute here itself. We're going to substitute v is equal to, so what is the expression for v? I don't have it here, I guess. So we have that to be m1 u1 divided by m1 plus m2. So if I do substitute, then I can further simplify this. So this will be half is common. Then m1 square u1 square divided by m1 plus m2. Right? The power over here is 1 and the denominator is square. So this will be left out. And we have m1 u1 square. So clearly you have just a second. So we have what? We have m1 common. And you have u1 square also common, sorry. And you're left out with m1 divided by m1 plus m2 minus 1. So the LCM and all of that, you will get minus m1 minus m2 divided by m1 plus m2. So we have half of m1 u1 square. So you left out with minus m2 divided by m1 plus m2. So you can see that there is a negative sign indicating there is loss of kinetic energy. So this will be half of m1 m2 divided by m1 plus m2 times of u1 square. So this is your change in kinetic energy. The negative sign indicates loss of kinetic energy. Okay, so that's the whole point of inelastic collision. So we also need to figure out in terms of ratio. So ratio, so we can just go with Kf by Ki, I guess. Kei. So this will be half of V square divided by M1 plus M2. In the denominator, we have half of M1 U1 square. Okay. And then again, we can substitute for V1. I know I should have done it before only. So substituting for V. So we have V is equal to M1 U1 divided by M1 plus M2. So if I do substitute, will I get to cancel something? Half of M1 square by U1 divided by M1 plus M2 into 2 by M1 U1 square. So yeah, there are a few things that we can get to cancel. And 2 and 2. So this is M1 by M1 plus M2. Okay, that's a weird result. Oh yeah, my bad. This is also squared, nah? You're squaring the entire thing. So this entire thing gets cancelled, my bad. So it's basically this, So clearly your KEF is lesser than KEI. That is the kinetic energy final is lesser than kinetic energy initial. And the ratio is this M1 divided by M1 plus M2. Okay, so this is also a proof for loss of energy during inelastic collision. Sorry, I didn't put a proper heading over here. We should actually. So this being the text. So we have comparison in ratio. Okay, now it's okay.